Hi, remember I was saying I have something new? I do, I really do. Look at this. So what you're seeing there are the ionic bond disc model the way that I get them from the manufacturer. So this is a +1 ion, you see, and it's blank. And then I have a +2. Oops, there's one here. Here's a +2. Loses 2 electrons, so it's 2+, or 3 electrons, or 4, like tin 4 or lead 4. This would be like, chromium 3 or aluminum, and this would be like magnesium ion and so forth, okay? And then over here, I have -1, -2, and -3, like for nitride ion and sulfide ion and chloride ion, for example. So with those 20 discs, you can make literally everything. I mean, there could probably be some really bizarre ones in the middle of the transition metals or something, that are +5 or +7 or something like that. I don't have those. I go from +1 to +4 and -1 to -3. That covers 99% of the stuff, though. So let's say that you want to make, cesium bromide. Okay? Look at this. So let's say we're going to make cesium bromide, like I said. Okay, so cesium is +1, bromide is -1. Now, we would write it, though, without the plus and minus. We would write CSBr, right? Okay, now, watch this. So, first of all, I have a set of stickers. And I can write those things on the stickers and put them on. Watch. So here, if you look, I've got a cesium, CS+, and bromide, Br-. Let me stick them on now, watch. Now you see I've got one that's labeled cesium, one that's labeled bromide, and they stick together. So I have cesium bromide. It's obvious, okay? On the back side, I usually have the name of the ion and the molar mass and so forth, and that's easy to do. But what this means now is that you can make literally anything you want. This is cesium bromide. Let's see what else we can make. Now, those labels go on and off really easily. It's not a problem, or you can just put another label on top, and there's next to no residue. They're easy to write on. If there is any residue at all, a drop of acetone or mineral spirits, a paint thinner, takes it right off, and the plastic isn't damaged at all, basically. All right, now, let's see what else we can make. How about if we made, aluminum phosphide? Do you know what the formula is for aluminum phosphide? Aluminum, it's got a charge of 3+, it loses 3 electrons, and phosphide picks up 3 electrons, it's got a charge of 3-. Both of them lose or gain electrons so they can be more stable. All right, so now I went ahead and I labeled the stickers, and I have a cation here that's ready for that aluminum, and I have the one here that's ready for the phosphide. Let's put it together. Now I have an aluminum and I have a phosphide. And let me put it together now. And you can see I've got 1- on top of each plus. You see if I take one of these off of here, you can see the plus underneath, and it sticks together. That's aluminum phosphide. And the way we would write that is ALP. That's all there is to it. So with those 20 discs, you can make anything practically, okay? And so you can see the right proportions. So if you think about covalent bonds and the ball and stick model kind of thing, and you can make most everything with them, well, this is the same deal. You can make that, and you can change the labels or add more labels on, or you can have students do it and try it. If this is of interest, let me know. And I'm going to put it out there. It'll be for sale on Amazon and on my website, Science Glenn, and the price is going to be surprisingly low. You're going to like it a lot. All right. Best of luck.